Okay, welcome. Thanks for coming, y'all. So this is From Nothing to Mario in 2 hours. This is one of our favorite classes, really. It's a series of classes that we've built. We do them on Flappy Bird, Mario, as well as Snake, where we take you guys from knowing conceivably nothing about Unity or C# game development into building your own games in under 2 hours. So we're going to get you a functional version of Mario in just 2 hours. Now, there are a couple of caveats to that. So I'm going to show you the version of Mario that you will finish, and you will see it is simple. It's nothing special, but it does function, and it will get you, hopefully, the intention is it will get you sort of over the hump of game development. So first of all, we don't have any animations or anything like that. We have a pretty static background, but we have a Mario that moves back and forth. He can land on platforms. He can jump. He can collect coins. He can run into piranha plants and die. And should we restart the game, he can indeed get to that flag back there and actually win the game as well. So the way that we make this functional, the way that we make it so that we can finish, a class on building an entire game in 2 hours with people who don't know what they're doing, is we give you a lot of the setup ahead of time. So this is an introduction to how Unity works. We're going to cover the IDE and some of the tools, etc. And it is an introduction to C#. So you will be writing at least 2 scripts by yourself, but then there will be a number of other scripts that are already pre-written for you. So the main intention of the class is to get you just over that hump of game development, that sort of that like scary line of, man, I don't know what the hell is happening, to, okay, I can at least make a game. So this is not going to be the class that gets you a job. This is going to be the class that gets you enough information to continue to learn as you move forward. All right, so here's Noah. So a couple of rules for us before we begin. Rule number 1, if you are comfortable and you have the capability to do so, I would love to see your faces. It helps me as a teacher deliver better instruction, to be able to actually see you as you go, so that I can, see that somebody is like, what the heck is going on, and stop and pause and figure things out. Number 2, if you are not currently talking to me, please keep yourself muted just so that we don't hear the dog barking in the background. But you are more than welcome to unmute yourself to ask questions. I actually prefer that you ask questions as we go. It's much more valuable to me to find out that you're having some kind of issue, or I wasn't clear enough on something right now, than it is to find out in half an hour when you are hopelessly far behind. So Jackson, Alexi, Noah, Kirk already knows this very well. If you run into any problems, please let me know as soon as possible and we'll get you fixed up. All right. And the last rule, and maybe the most important rule, let's keep this a fun, encouraging, kind learning environment. In these classes, inevitably, there will be people with more experience and people with less experience. So if you are one of those who are more experienced, take deep breaths, stay calm when I'm covering things that you already know. And if you are somebody with less experience, remember that any questions you got is going to be valuable to the rest of the group. So don't hesitate to say, yeah, my Mario is currently upside down and I don't know why. That is totally fine. We'll help figure it out. All right, so let's begin. First things first, does everybody have Unity installed? Because that is a pretty important step.
Yes.
Okay. It happens almost every time there's at least one person. For anyone, let me grab the download link here. For anybody else who might not have it installed, here is the link to download Unity Hub. So the way that this works, I can start screen sharing. We can jump in. The way that Unity works is relatively recently, and when I say that, that means like 5 or 6 years at this point, so really not that recently anymore. Unity Hub got introduced to handle the different versions of Unity and the different projects in Unity. In the olden days, you would literally have multiple applications, Unity 2020.2, Unity 2020.3 on your computer, and you would have to open up the subfolder of the game that you wanted with those different versions. Now we have Unity Hub. So what you're going to install first is Unity Hub. Inside of Unity Hub, you're going to create a free account, and then you're going to manage your license, which you can use a personal license for pretty much forever until you're making really serious money. They don't require you to get a paid license until you're making 100 grand or more on the games you're working on. So download Unity Hub, make a free account, sign in, set up a license, and then install the most recent version of Unity. If you are out of date, for anyone who is taking the class right now, not a big deal. For the most part, unless you're really dramatically out of date, you're going to be able to follow the class just fine, even with a slightly older version. I do have the most recent install here, which is 2020.3.27 F1. All right. So we should conceivably have Unity Hub all set up. The next step is to actually make a game. So in your project tab, you're going to click New Project. And this is a little bit new. This has been updated recently, Unity Hub, where you actually have a couple of different samples and learning environments that you can play around with, which I definitely encourage all of you to experiment with. So for instance, here's a 2D platformer micro game, which is kind of interesting. We're not going to start with that. We're going to run this ourselves from scratch. So just click on the core section, click on 2D, and then come down here in the right-hand side where it says project name. You can name this whatever the heck you want. I'm going to call it Mario with Game Dev Drink Up. And then I always recommend that you have some kind of workspace folder where you keep all your code. Mine is literally called workspace. So I will select that folder and hit create project. All right. Now, periodically, I'm going to be checking in with you. For those who have mics, feel free to jump in and talk to me. For those who don't have mics, feel free to use the chat. I do my best to watch both while I am teaching. So as I ask questions, please jump in, answer things, etc. So first question is just, does everybody have Unity Hub set up? And do you have a new project creating right now, or do you already have a new project set up? Jackson, do you have a new project?
Yes, I have the project set up and everything. Yes.
Fantastic. What about you, Kirk?
Just opening up the project. Yeah.
Fantastic. And Alexi and Noah, how y'all doing? Also welcome. I didn't say hi to Noah. Going great. Fantastic. Okay, so let us begin. Oh, this is interesting. So this actually saved the layout from the last time I taught the class. However, your layout probably looks more like this. So the very first thing that we're going to do is manipulate Unity so that it is a little bit more user-friendly or approachable for fresh game developers. This is the default layout. I'm not exactly sure why this is the default layout because I don't think it's optimal. So we're going to do a couple of things here. The Unity, this is what we call the Unity IDE, to give you a little bit of lingo that you can impress people in your next interview. Anybody know what an IDE is?
An integrated development environment.
Ah, yeah, 10 points for Kirk. Yeah, so an integrated development environment. Back in the olden days, which game development has progressed so ridiculously quickly. I've been building games for probably 13, 14 years now. And when I say back in the day, this means like 8 years ago, like before Unity was really mainstream. Back in the day, 8 or so years ago, we used to build games primarily anyway through just like text files and images. So you would actually be coding a single text file, and then you would have some kind of separate emulator or simulator to run the game and actually see how it looks. Or you would even more heinous than that, you'd have to put it on device, build it to your phone or your Switch or whatever you're actually building for every single time you wanted to test your changes. Terrible, mind-bogglingly terrible. So much time wasted. Now we have Unity and its IDE. There are plenty of other IDEs out there, but Unity is definitely the most popular today. So this is an IDE, an integrated development environment. Imagine like a Photoshop for building games. Instead of just editing code and moving pictures around, we actually have a visual way to build our games. We're definitely still going to be coding. Don't get me wrong. Some people think that they can build games without coding, and they're wrong, unless you're using sort of a pre-existing game engine, which or game editor that touts not having code. But even then, usually they have like pseudocode. So pretty much you're going to have to code if you want to make games. Now, in Unity's IDE, these different tabs, there are 6 sort of key tabs: your hierarchy, scene, game, inspector, project, and console. All do something different. We're going to talk about them as we go. And they also can all be moved and manipulated around the screen. So the first thing that I'm going to ask, like I was saying, is to move your tabs around to more closely match what I think is a user-friendly version of the UI. So first, we're going to click and drag this game tab. We can see that currently we have 2 tabs next to each other, the scene and the game. We want those to be separate. So we're going to click and drag the game tab over to kind of the middle right. If you're already fairly comfortable with Unity or have already made a game or two, feel free to use the layout that you like, but matching my layout is going to help you follow along with the class today. And if I need to help you fix anything on your computer, it'll help me understand how stuff works so we'll be able to fix the problem faster. So your goal here is to have the scene and the game tab separate. Then down here in the project and console tab, I'm going to do the exact same thing. I'm going to click and drag the console down to sort of the bottom right so that we have the console and the project here in their own tabs. And the console typically wants to be nice and wide, and the project can be pretty small. So I'm also going to click and drag the separator bar pretty far over so that the console is nice and big. All right. And the last thing I'm going to do in a project tab in the bottom left, there are these 3 little dots. I'm going to click those dots. I'm going to click 2-column layout. Oh, no, actually 1-column layout. Right. It saved my stuff from last time. By default, it will probably be 2-column layout. I'm going to switch to 1-column layout. 2-column is more similar to like Adobe Premiere or other file explorers where you have subfolders that then shows you all the contents of the folder. 1-file layout is, or 1-column layout is more similar to like Finder or Classic File Explorer on PC, where you just have the folders with the files actually underneath them. This is how I prefer it. And also I think it's a little bit more user-friendly, but feel free to do it either way. Okay, everybody good so far? Once again, I'm gonna have these check-in moments as best I can, but it's way easier if you just say, hey, I'm lost. Okay, then we shall continue. So the next thing to do is to actually add something to our game. Right now, oh, excuse me, I've jumped forward. Next thing we're gonna do is talk about what each of these tabs actually does. So the place to start is the scene tab. Now, Unity is built with a sort of scene layout. Anybody know what a scene is in Unity? No, at least Kirk does. What's a scene, Kirk?
A scene is the game engine's way of containerizing portions of your game. So you can think about it as, you're a director and you're trying to set the stage for the game. So maybe your main game scene would control all of your main gameplay. So it'd be the thing you see after you go through your start menu and like see a loading screen in maybe a multiplayer shooter like Call of Duty. Yeah. And then the actual main game scene is you and the characters with your loadouts, like, fighting each other on a map.
Love that. Yep, that's pretty much right. So the scene tab itself, this location, this tab is like our behind the scenes. This is sort of, this is us looking into the ether of the game. This is where we're going to be editing the levels. This is where we're going to actually change how stuff looks in our game. And a scene itself, when you say I'm opening one scene or I'm opening the other scene, is you can kind of think of that like a level. So oftentimes Unity games will have multiple scenes inside of them and you will open any one scene at a time. So if we're talking Mario, World 1-1 is going to be its own scene, and then World 1-2 is going to be its own scene. Noah says the menu itself also is its own scene, if I recall correctly. Yeah, so different games will do it different ways, Noah, but a main menu or really any menu system is another common example of when we will use a separated scene. So one of the apps that I worked on for a while was called You and Me. It was video games for cats, which was super fascinating. And we had scenes for like everything. We had a scene for the main menu. We had a scene for the payment page. We had a scene for the, what else? For like the game select screen. So that way you can compartmentalize what you're editing at any one moment. For our game today, because it's such a small game, just this little sort of example platformer, we're going to be making our entire game in this sample scene. And we won't bother having multiple scenes. So that's what the scene tab does. It's us editing the current scene. It's where we're actually going to lay out the level. It will become more clear as we go. And then the hierarchy here on the left-hand side is just like a list of all the things that currently exist in our scene. Now, this is going to come across as a little like Blue's Cluesy, but there's currently one thing that exists in the current scene. What is it?
A camera.
Yeah, Jackson. Wow. You too, Noah. Congratulations. Everybody nailed it. Alexa, you got to pick up your game. I'm just kidding. You're doing great. Yes. So the main camera is currently the only thing that exists in the scene. And we can see that by looking at the hierarchy. And right there is the main camera. And there's nothing else underneath it. So this, by clicking on the main camera, will bring us over to the next tab, which is the inspector all the way on the right-hand side. The inspector tells us everything there is to know about the currently selected game object. I'm going to say that one more time. The inspector tells us everything there is to know about the currently selected game object. Game objects are a special Unity term. Unity developers made it up, but now, it's canon. It basically just means something that can exist in the scene. So the main camera is a game object. And when we're going to talk about components in a second. When we talk about components, there will be even more nuance to what a game object is, but anything that's in our hierarchy is a game object. So by clicking on our main camera, we can see all of this information about the main camera over in the inspector. So for instance, we can see its actual position in space. Right now it's at 0, 0, -10. We can also see the first thing that I'm going to have you edit, which is this background. So if I look under camera, this is actually the camera component. Once again, we'll get to that in a moment. And then we'll see that there's this background variable here with a big blue box. If you click the big blue box, there's going to be a color wheel that pops up. And this will actually allow you to set the default background color of your game. So figure out what kind of platformer you want to make, what version of Mario you want to make, and then, you know, find the right vibe for it. I don't know. And the last time I taught this, I went for like a purple, but I'm feeling like a peach right now. Yeah. Got to go save Princess Peach. I don't know. So that is the first thing you can edit in your game. Congratulations. You are Unity game developers. Go to the main camera, go to the inspector, go to the background, click this big box, and change it to a color of your choice. So that's how the, good job, Noah. Good job, son. So that's how we edit things in the inspector. So all of these different things do different things. And we'll show you some more examples right now. Don't play with the camera too much because you might wind up not being able to see your game very well, but we'll have other examples for stuff for you to play with. All right, so quickly finishing up our tabs, and then we're going to add our first sprite to the game. In the bottom left, we have a project tab. The project tab is equivalent to like the library in Photoshop. This is where all of the assets that we have available to us to make this game exist. So for instance, if we are building the current scene, World 1-1 in Mario, and so there's, you know, Goombas, and there's the pole that you actually go and get, right? And there's like power-ups and stuff. All of that will exist in the scene, but Bowser won't be in the scene because he's in a much later level. And so he's in a totally different scene. But Bowser will still be in the project because he's one asset that we have available to us to make the game. So the project is just like all the stuff. That's our art palette, kind of. Our console is in the bottom here. This is like our warning lights. If you are at all familiar with any coding language, a console will be very familiar to you. This is sort of a developer environment exclusive. So when an actual human, when a user is playing your game, they will not be able to see anything in this console. But while you are testing your game here in Unity, it will show you everything in the console. So if you have a problem, if you have a bug in your code or something, it'll pop up here in the console, which is why you want it to be nice and big and obvious. All right, so that leaves just one tab that I haven't mentioned, which is this game tab. Can anybody guess what the game tab do?
Shows the game.
Wow, really cracked that mystery. Yeah, so this is another thing that makes Unity special. They are not the first to do this, but they are the first really to popularize it, I guess. There's an actual simulator or emulator, a thing that can actually run our game right here in Unity in our IDE. So at any moment, we can actually play our game without having to put it on a phone, without having to put it on a Switch, without even having to open up a simulator on our computer. We can just run the game right from here. And it changes how quickly you can develop dramatically. For many of you who are just getting into this now, this is sort of the norm now, which is fantastic. Very happy for you. But when I first started, the time between getting my game ready to test and actually testing it was 10 times what it is now, thanks to Unity and other engines just like this. Okay, so we know what all of our tabs are. Let's add our first thing to the world. We're going to start with a platform for Mario to stand on. So up in the top left of our hierarchy, we're going to push that big plus button there. And when you click the button, you'll see a drop down. Go down to 2D object, go down to sprites, and go down to square. If you have an older version of Unity, it might only say sprite instead of sprites, and it won't have other options. Let me know if that's the case, and I can point you in the right direction. All right, so we have a square in our world, and we can see that the square appears both, actually in 3 locations. It appears in our hierarchy, so it's a game object. We know that it exists in the scene. We can see it in the scene itself, and we can see it in the game. I'm going to point out how all of our manipulation tools here in the top left work really quickly as well. Once again, we're sort of assuming that you don't have any knowledge. The first tool here in the very top left is our move tool. This allows us to move around the world. That's really all it does. This is not really necessary in 2D. Here's actually a hot tip for you. So if you have any of the other tools selected, so you can click the move tool just to demonstrate this. If I click, now it's doing the move tool stuff. But if I right click, it'll actually still do the hand tool. So you can right click to get the hand tool at any moment, just to quickly move around your world. All right,
clicking
so
middle mouse button also does the same thing with move.
Oh, I didn't know that. Awesome.
Yeah.
So clicking on your square with a move tool selected shows these beautiful two little arrows. This is exactly what it sounds like. This is the ability for you to actually move this sprite around the world. Clicking one arrow moves it along one axis. Here it is moving along the y-axis. Clicking the other arrow moves us along the x-axis, and clicking the square in the middle moves us along both. The rotate tool does something similar. You can see this blue circle will rotate us along the z-axis, but then stuff gets weird when you rotate the other two circles. So if I rotate this one, this is rotating us along the x-axis, and this is rotating us along the y-axis. But this two-dimensional square sure looks like it's in 3D right now, doesn't it? Anybody tell me why that is? It's a plot twist coming.
Yeah. Unity tends to load its projects in a default 3D state, and it emulates 2D through a perspective view instead of an orthographic view. So you technically still have all three axes, even though it's a 2D project. So be mindful about your axes when designing 2D projects.
Yes, Kirk is a smart guy, and he said smart words, but the short version of that is this is actually a 3D game. What the hell, we've been lied to. So Unity, this is actually a relatively important fact. And I will point out, I think 2 more moments that this actually matters. So here's the important fact. I'm going to say it twice. Unity was built for 3D games first, and then the functionality to support what looks like a 2D game was added later. Unity was built for 3D games first, two-dimensional functionality was added later. So this 2D game that we just started is actually a 3D game. However, we'll notice that this square right here, when I move it further or closer to the camera, it doesn't look like the square is getting further or closer. And that's because one of the main differences between a 2D world and a 3D world, at least in Unity, is how our camera is set up. If I click on my main camera and I come down to the camera component, we can see this projection mode right here is currently orthographic. Orthographic means no matter the distance, I'm going to draw these squares at these objects at their real size. If I switch to perspective, now this is more of what we would expect in a 3D game. And if I move this away, it would actually get closer and further from the camera. So we don't want that. That was just to show you this important fact that Unity actually is a 3D game engine. Switch this back to orthographic if you did switch it to perspective, and we can continue. There are a few moments. This little toggle button is how you switch between 2D and 3D mode right here in the scene. There are a few moments where that will really matter. And that is one of the ways that it matters is just to explain why our rotation sure looks like it's in 3D. And it looks that way because it is in 3D. All right, next tool. Let's continue with these tools. So the scale tool allows us to scale along one axis, the other, or both, just like the move tool. The rect tool is one of my favorites. This is probably what I use the majority of the time. It gives us these 4 little corners. Imagine like Microsoft Word or Photoshop again, when you are transforming something, when you're free transforming. I can click and drag just one corner. I can click and drag just one side. I can shift click to keep the aspect ratio the same. I can move my mouse kind of further away from the corner so that I get a rotation. And if I click on the image itself, I can move the image. I can drag it around. So the rect tool happens to be the one that sort of feels the best for me. You can experiment and find how you like to use the world, use Unity. The next tool is the insanity tool, also known as move, rotate, or scale selected objects tool. This has all of the tools in one for people, I don't know, for robots to use. I've always found this way more confusing than it's worth, but hey, if it makes you happy, go ahead and use it. Now you know how it works. All right. So now that we have a super messed up platform, let's reset this thing. One other thing that's very important to remember is that you can always edit your values in the inspector. So even though I have these tools at my disposal, we'll see that all of these values have been reflected in the transform component of the square. So if I wanted to fix my crazy rotation, I could reset my X to 0, and then my Y rotation to 0, and then my Z rotation to 0, and then I have an unrotated square. But a shortcut for you, for any component, so transform as a component, sprite renderer as a component, I can reset this component to its default values by clicking these 3 little dots in the top right and clicking reset. And that's what you should do, unless you want a giant platform, which is, all right, you're making this game, I'm not making this game. All right, so that's all the tools in Unity. Let's get some interactions actually working between objects. I want you in the top left. Anybody, actually, not to move too quickly, does anybody have any questions, comments, concerns, thoughts, opinions, feelings before we keep going? We're about to add Mario to our world.
I'm doing pretty good. Thank you.
Of course, great. Glad. All right. It's a very friendly room. I'm enjoying it. So we're going to go back up to the hierarchy in the top left, click our plus button again, go to 2D object, sprites, and this time we're going to do a circle. No real reason, just to differentiate it. We're going to actually replace this with the real image of Mario in a moment, but just to differentiate it for now. All right. So let's also rename these things so it's more clear. So if I click on my square, we can see in the inspector in the very, very top, there's a box where it says square. That's where you can actually rename this thing. So I'm going to rename it platform. And then I will rename my circle to Mario. I believe, yeah. So you can also click once and wait a moment to rename an object. So you can see here, I can click and rename it right here just to Mario, or I can even right click and hit rename. 3 different ways for you to rename your objects. All right, so we have Mario and a platform. Now, the last buttons in the inspector, or at least some of the last buttons that I didn't really show you, are the play, pause, and step over buttons here in the top middle. This is how we actually get the game to run in our emulator or simulator. When I click play, my game will actually run as if the player is picking up the phone or the Switch or whatever device you're actually playing this game on. When I click pause, the game as it's running will actually pause for a moment so that I can try to fix things. It's very useful to debug problems or just see what's happening in your game. And when I do step over, this is a much more complicated code debug tool. And for the most part, you won't use it for your first couple of months as a developer. But when you set up breakpoints, is what they're called, if you want to look it up for yourself, in your code editor, whatever code editor you're using, this is actually going to engage with those breakpoints to allow you to more slowly look through your code. But yeah, I want you to hit play right now. And when I hit play, what do we think is going to happen with this ball and this platform when the game starts running?
If I had to guess, nothing.
What? Are you serious? You're right. So we maybe would have expected those things to fall or to somehow interact with each other. But we can see my game is currently running and nothing is happening. So Jackson was totally right. By the way, if you're curious about why I keep doing this stuff, it's because the zoom controls always get in the way. It's really fun trying to manage it all. But the reason that nothing happened is because we didn't tell anything to happen. Noah also nailed it. Congrats, Noah. Alexi, I'm sure you nailed it too. So we didn't actually tell Unity that we want anything to happen to these objects. And by default, Unity is not just going to like assume that you want the ball to fall or something like that. So the first thing that we have to do is to add physics to Mario. So Mario actually has gravity applied to him. We can do that by adding a component. So does anybody know what component-based programming is? Yeah, no gravity exists yet. What is component-based programming? Yeah.
I came from an object-oriented perspective, but I'm learning the entity component system standard that Unity operates on. Essentially, It's the idea that instead of where OOP has base classes, derived classes, abstracted classes, and more, everything is an object, and an object can have components, and those components can be other objects. So they're basically clusters of properties or rules that are, made into these components that you can change in order to define the properties or behaviors of an object.
Yeah. So the sort of metaphor that I like to use or example that I like to use that I feel like demonstrates it the best. I actually like to compare this to object-oriented programming. So a more classic way of programming is object-oriented. It still gets used today. We'll actually still use it in today's class. But the concept in object-oriented programming is that I write a single script for the most part that encapsulates everything that has to do with a single like object or thing in my world. So if I have a dog, I would write a dog script, and that dog script would know how to play the animations for the dog, would know how to make the dog pant, would know how to make the dog get pets or something. In component-based programming, instead of doing that, we would write multiple components that we attach to a single empty game object that eventually makes it look and feel like a dog. So instead of writing dog, we would write a script called like tail, and we would write a script called mover, and we write a script called like shaggy fur. These are generalized, but that's basically the idea. And then when you attach all these things, you write the licking script. When you attach all these things to the dog, suddenly it is a dog. So instead of writing the bulk or object that you're aiming for, you're writing the pieces. That's really the core difference. Anybody know why that's valuable? Why did Unity decide to do that?
Probably because there's a lot of overlap. Like a lot of objects will use the same few things, like physics or whatever.
Bingo. I need like a little like congrats bell or something. Yes, exactly that. Two parts. That for sure. Reusability or robustness. So now if I need a cat in object oriented, I'd be like, ah, shit, now I got to write a cat. In component based, I take the moving script and I take the tail wagging script and I take, maybe the licking script too, and I stick those all on another game object. But this time I add the meow script and now it's a cat, right? So reusability is a big part of why we do component based programming. The other part is to help us basically debug. So if for some reason the dog isn't barking and instead is making elephant sounds, we can go straight to the bark script, and that's probably where the issue lies. So Unity is component based. And the reason that matters, why we're talking about that now, is if we look at Mario and we look at the main camera, both Mario and the main camera already have two components attached to them by default. So what are the two components for either Mario or the main camera?
So for Mario, it seems to be a renderer and then the normal transform, right?
Yep, exactly. So for Mario, we have a sprite renderer and a transform. For the main camera, we have a transform and we have a camera. Now, by the way, this camera component, while it is still a component, is a little bit more in the object-oriented land, because this is one component that kind of does all the things that a camera needs to know how to do. On Mario, instead, we have a transform, which is a component that just knows about position in space. So it knows where we exist, where we are. And then it has a sprite renderer, which just draws an image. It renders a sprite. Now, Noah asks, would you not need to customize each component to behave uniquely for each instance? You are totally right, Noah. And that is one of the ways that we write code. We write code in a way so that these components can be edited. So our sprite renderer here, we can see on our platform, has a sprite called square. On Mario, our sprite renderer has a sprite called circle. So these both have a sprite renderer, but just by surfacing this one variable called sprite and changing which image is in that sprite, it changes the behavior of the object. So if we had like a, make noise script for our dog and our cat, we could add a bark to one and a meow to the other, and it would be using the same component, but we would have the functionality of both the dog and the cat.
Also, this is a little bit off topic, but
yeah.
So there's a camera component for the camera object. I assume that's because I've never made a first-person game in Unity, so I assume that's so that you can attach a camera to like your player or to some like a third-party like third vision camera or something like that.
Yeah. You're pretty much right. It's sort of, that's actually interesting. For any new project that you make in Unity, we'll start with a main camera. And it will start with a couple of values defaulted in here. You're allowed to use the camera component. So you can sometimes have multiple cameras. That's like somewhat unusual. The case where you might do that is if you have like a mini map maybe, or like a security camera that actually is looking at something else in the scene.
Like a security camera or
something like that.
Like a drone or something like that.
Yeah, exactly. Yeah. But for the most part, we can actually, so in our level 2 class, we do a big platformer, and we used to do a first-person shooter game. And in that case, you would actually just take the camera object, this actual object, and just stick it inside of your player so that when the player rotates, the camera also rotates with them.
That's what I thought. Yeah. Okay, cool. Thank you.
Yep. No problem. All right, so let's get back to it. We talk about components, and we talk about components because we're going to add our first component now. So on Mario, in order to give Mario some physics, we're going to click on Mario, and we'll see that in the inspector towards the bottom, there's an add component button that we can click. We want to add physics to Mario, which if I type physics, there's physics raycasters, but that's actually not what we want. This is a bit strangely named, but you're actually going to look for the rigid body component. Now, here is the first moment where it matters that Unity started as 3D and then kind of became 2D later. We have a rigid body 2D and we have a rigid body. Which of these should we click, do you think?
I'm going to go with 2D.
Yeah. And what do you think this rigid body one is?
Some kind of 3D.
Yep, that is the 3D rigid body. So if we want 3D physics in our 2D game, we can click this, but that will make weird shit happen. So click rigid body 2D for me. And now that's actually it. We actually have physics in our game now. If we click play, Mario will gracefully fall and land on the plastic. Shit, he went straight through it. So that was actually exactly what we hoped to happen. So Mario now has physics applied to him. Gravity applies to Mario, pulls him down. However, he does go straight through the platform. So given what we just talked about, anybody guess why Mario just went straight through the platform?
Yeah, what Noah said. So just because Mario has some kind of physics doesn't mean that there's any collision or that yeah.
Yeah, nailed it. Yes. Good job, Noah. Good job, Jackson. Yeah, we added a physics component. The rigid body is an entity that just knows all the physics stuff. So it knows how to add velocity, it knows how to have mass, it knows how to have drag, but it doesn't know about actually colliding. That's another separate component, another component that we can attach to add physics to our character. We may not want both sometimes. That's why they are separated. So there may be, I don't know, like maybe a bird in the background, right? That the player would never be able to run into, but we still want it to like fly around and have gravity and stuff. So we would have a rigid body, we wouldn't have a collider. So in order to make these things actually hit each other, we're going to add a collider to both of them. So on Mario, we're going to scroll down here. We're going to click Add Component, and we're going to search for Collider. And here is the second moment where it matters that this is a 2D game and not a 3D game. We can see a ton of different collider options. And for the most part, you are just trying to pick the collider that you think is going to fit the shape of the thing best. In this case, it's a circle. We're going to add Mario to it later, though. So I actually want you to pick Capsule Collider 2D. Now, as soon as I add that, it's a bit hard to see, but can you guys tell that there's yeah, there we go. If I zoom way in, there's a green outline that goes all the way around this circle here. That is actually our hitbox. That is the collider. So this is Unity's little debug. You can see that that green circle is not visible in the game, but this actually, yeah, no collision on either of them, right? No, but this actually shows where this circle will collide with other stuff. Now, the platform still needs a collider. If I hit play, the ball is still going to fall through the platform. The platform also needs to know that it's supposed to collide with the stuff. So I'm going to click on the platform. I'm going to click Add Component. I'm going to search for, sorry about that. I'm going to search for Box Collider 2D. You can see it right here. And I'm going to click it. Once again, for the most part, you're just picking the collider that's going to fit the shape best. This is a square, so the box collider is perfect. All right, so we can just barely, it's pretty hard to see, but we can just barely see the green outline on this. If it doesn't perfectly match the size of the object, so here if I made the collider a little bit bigger, you can see the hitbox or collider much more easily. But in this case, Unity is doing its best to snap to the size of the object you attach this to, which since this is a square, it did perfectly. So now, if I hit play, we finally get the desired behavior. Wow, amazing. Best game of 2022. All right, this is a perfect time to check in. Do we have, does everybody have a ball that falls and lands on a platform? Alexia, I haven't heard from you. Let me know. Got a thumb from Jackson. Noah, hopefully you're okay. Let me know if not.
Things are working on my end.
Fantastic. Alexi says thumbs. Thank you, Alexi. Okay, so let's go ahead and move forward then. So we now have sort of the building blocks of our game. We're going to have to write some code ourselves to make Mario actually move around, but the physics of our game is now done. If we wanted to, we could make a million platforms and actually design a whole level now, right? But before we get there, let's make our game look a little bit more like Mario. So besides the fact that you downloaded Unity, I also want you to download our asset pack that we created for you guys. It's just a Google Drive folder. I will share, where's the share button? I will share this with you. So if you go to this folder, there is a bunch of stuff that we have prepared for you. There is a handout that is going to give you some sort of an overview of what we talk about today, as well as some next steps. There are sound effects in there. There's a little GIF of what you should expect to be able to make. Wow, amazing, beautiful. There's images, and then probably most importantly is our scripts. So we're going to write some scripts here together, but you have all of the scripts available to you, even the ones that we're going to write together, so that you can look back at these if you have any problems, or if all else fails, you can just use my script instead of yours. Like I said, this class is all about just getting you over that very first hump so that you can make your own games. So what I would like you to do is you can download the entire folder by right-clicking on Mario in 2 hours and clicking download. But if that isn't working, for some reason, some people have problems with that. Or if you don't want to download the whole folder, you can always download one image or one script at a time. What I actually need you to grab right now is the brickandmario.png. Brick and Mario PNG. I think I already have it downloaded. Yep. Brick and Mario.png. I deleted Mario in the last class. Hold on, I'm going to re-download. So here, I'll just grab Mario by himself. All right. So to import any asset into Unity, anything that you can actually use in Unity, images, sounds, scripts, etc., all you actually have to do is drag and drop the assets into the project folder. So I'm going to click and drag Mario here, mario.png, and I'm going to drop him straight into the project folder. I'm going to keep it under the assets folder. The packages folder is like all Unity's built-in stuff. So you want to keep those separate. It's pretty easy to get disorganized. So keep it in the assets folder, but then just drag and drop it straight into project, and you'll see that Unity imports Mario. A small note about this. This is a duplicated file. So we can see that Mario is still here. It didn't move the file. It's also not referencing it. If I delete Mario, and this is why it wasn't in my folder before. If I delete Mario, if Mario gets lost or something, scary. I'm not gonna do that right now. If I delete Mario, we can see that Unity still has it just fine. So it is actually duplicating this file and keeping a copy of it in your Unity project. All right, now you can grab all the other images if you have this whole thing downloaded, or at least the brick as well. I'm just going to click and drag this entire images folder into my assets. If you don't have an images folder, you can always click plus and go to folder here and make an images folder for yourself. I'm going to drag Mario into that images folder, stay organized. Pretty easy to get disorganized up in here. Okay, so let's replace the platform and Mario. Right now, the chat, make sure everyone's good. Okay. Right now, the easier one to do is probably going to be the platform. So click on your platform and go over to the sprite renderer. And we can see that the sprite right now is square. Now, whenever we have a big empty box like this, especially one with a little circle on the right-hand side, that actually means that we're allowed to drag and drop into this box. So instead of having to hook up some code that points to the correct image, like we would have had to do in the good old days, now we can just drag and drop. So I can click and drag Mario from my project into that empty box right there and let go. Oh, I forgot, this is the platform. I can click and drag the brick into this empty box right here. And suddenly my platform looks like a brick and not a white square. All right. Now, something that you'll notice is that my collider is currently really little. And the reason for that is the collider does not automatically update when you add new images. So it's actually still the same size as when this was a white square. And you'll see that even though it looks this way, it will still function. Let me move this back a little bit. It will still function. So the ball is still colliding with the square, but the square is obviously not the correct size and proportion to the new image. We can fix that really easily by clicking on our platform, going to the box collider 2D, clicking on these three little dots and just hitting reset. And this will do the exact same functionality it did before, where it attempts to snap to the size of the image. And you can see that it's now correctly snapped to the size of the platform. Now, that being said, the platform does seem quite big, so we can also scale it down a little bit. Maybe, I don't know, what does a 0.5 look like? Yeah, that seems okay. So the platform is a good size, and you can see that once we reset that the collider one time, the collider will still get affected by the scale, so we don't need to reset the collider again. Okay. As always, let me know if anyone's having issues. Okay. So let's reset Mario's image as well. I'm going to show you a second way to input sprites as well as any sort of empty box like this that you see. Whenever you have a little circle here, you're actually allowed to click that little circle, and that'll bring up a dialog box with all of the options that are available for this current thing. In this case, it's a sprite. And you can see that Unity has a ton of defaults in here. It didn't used to have this, and I actually feel like this is a poor addition because it kind of just clutters everything up. But regardless, These are all sort of default images for Unity's asset packs, and our images are in here. Anything that can fit in this box, once again, in this case, a sprite, will be in this dialog box. Here's the brick, here's the coin. So in this case, searching is your friend, so I can search for Mario, and here's Mario right there. Now, Mario is kind of freaking massive, so we probably want to scale him down. What's a 0.2 look like, baby? Look at that, perfect. And now, just like the platform, the collider is way too small. So we can do the same thing where we go down to the capsule collider 2D, click the 3 little dots, and click reset. All right. Now, when I click play, is there an option to filter all default Unity assets from the search? That's a great question. I'm not sure. Let's see. That's kind of funny. It's now not showing me all that stuff. I don't know why. That's actually curious. Why did it just change? Is everybody, I'm curious, when you guys hit this little circle, are you guys seeing a million options, or are you only seeing a couple?
I am only seeing what you're seeing right now.
Strange. So here's another thing with Unity. It is so ludicrously populated with features that it will do weird shit sometimes. Like that. I encourage you not to throw up your hands. It'll still 95% of the time, if there's a problem that you run into, it'll still be something that you did. But occasionally Unity will still do something peculiar. Like, it's very strange that just a second ago it was showing me all of those options. And
so if you go back to that folder in the top right, you can toggle whether or not you want to show hidden packages. And so I think all of those are in hidden packages from the default Unity whatever.
Yeah, nice. Yeah, I didn't actually know that. That's perfect. So this must have been, it's weird that it started by showing it and then automatically closed it for me. But there's your option, Noah, that you were just asking about. So I didn't even know about this, but if you click this one, it will hide hidden packages. And that way you'll only get a couple. These ones here, even though we didn't add these are, this is old as time. These have been in Unity since Unity first got created. These are meant to give you some kind of sprite so that you can quickly prototype stuff. So these are actually meant to be there, even though they are default Unity sprites as well. All right. So anyway, so we have a Mario and we have a platform. And when we hit play, Mario will fall and land on the platform, but we'll notice a issue here. It's not too big a deal, and we could totally run this game and it would be fine. But Mario is floating in space a little bit. Why is he floating in space? Let's debug a little bit.
Well, you can see the collider is a perfect circle, and the circle goes below his feet, so kind of makes him float.
Yep. Yeah. So remember that the actual collision engine, the physics engine that is detecting that these two things are running into each other, doesn't care that the sprite, is floating in space. It doesn't care what the sprite actually looks like at all. It only cares about that green circle. It only cares about the collider. So this collider is a little bit bigger than Mario, a little bit longer than Mario, so he's currently floating in space. So just like anything else in the inspector, we can play with these values. So if we look at Mario and scroll down to his capsule collider, this, by the way, is why I chose a capsule collider and not a circle collider. I can mess with this X and Y value that we have here, this X and Y value that we have here, size, and I can try to make this a little bit more closely fit him. So it looks like a 5 or a 6 maybe on the x-axis seems to fit him. This will be different between our devices, but just so that you can see how I'm doing it. And let's see, what does an 8 look like? An 8 is a little closer, but it's still a little bit past his feet. So I might even make that, what about like a 7.5? That seems a little too low, 7.8, something like that. There we go. That looks decent. Now, this exact problem is actually a really interesting one. So remember that, once again, the green is what is actually going to cause collisions. So right now, if Mario's tip of his foot ran into something, it wouldn't detect the collision. But if this empty piece of space ran into something, it would detect the collision. So this is actually a bit of a balance that has kind of never been solved. Hitboxes are rarely perfectly matched to the image itself because it's really expensive on a system. It's very difficult for a system to process when colliders are too complex. So you could do, for instance, I'll actually show you, don't do this in your game, but I'll just show you, if I remove this component and I add a mesh collider 2D, or excuse me, it's called a polygon collider in 2D. If I add that, it'll attempt to draw a polygon that more closely matches Mario's perfect layout. This is great, especially if you're making like a fighting game or something where the collisions like really matter. It has to be pixel perfect. But the problem with this is it's more expensive on your CPU. So this is going to burn out your computer faster. So colliders are all about sort of matching like complexity versus value for your processor. So let's see. I'll revert these back. That looks about right. Okay, so we have a Mario who falls and lands on a platform, and now his collider is a little bit more perfect. This is some of the bug fixing you're going to be doing as a game developer. So I think it's about time. Let me check my notes here. Yeah, it's about time to start coding. Before we write our first piece of code, make yourself a couple of platforms here because we're going to make Mario able to move around in a second. So just duplicate a couple of these platforms. You can hit Command D when you have the platform selected on Mac or Control D on PC. You can also copy and paste. You can also do what's called a prefab, which I'm not going to teach you about right now for the sake of time. But if you look up prefabs, they're one of Unity's more powerful tools. And it basically allows you to duplicate stuff in a more holistic way. But I'm just going to make a couple of platforms here so that we can have something for Mario to go run up once we get his input working. So just slap a couple platforms in. Now ask a question. When you add a capsule collider, does it try to fit the sprite by default? Or is it default starting value? Yeah, so whenever you add any kind of collider, it is always trying to match the sprite to the best of its ability. Part of the reason actually, that Mario's keeps being too big when we first add it can be answered if we look at the image itself. What do we notice about Mario's image as opposed to the, actually, this is a great example. What do we notice about the coin versus Mario that makes us think maybe the collider is not going to be quite perfectly matched to Mario? Square aspect ratio. Yes, that's basically it. So like if we look at the brick's image, this is actually not quite right, but yeah, there we go. The brick's image perfectly goes to the edge of its memory. The sprite, on the other hand, Mario's sprite is square. So there's this big empty space on the side. Unity is not smart enough to realize that this is transparent, and so that we don't want a collider here. It does not affect, this is sort of interesting. It doesn't affect the simple colliders. It does affect the mesh collider. When I added, we can see here, when I added the, like, let's add a box collider. That'll be really obvious. When we add a box collider to Mario, it basically just draws a box around his actual image. And so it shows that empty space, really obvious. However, a mesh collider, the more expensive one on your processor, actually uses the points, the pixels of Mario to draw itself. And so therefore it does correctly ignore the empty space. So it's a bit different between different colliders. But anyway, getting too in the weeds. Great questions though, Noah, thank you. All right, so let's get Mario to actually start doing some stuff. We're gonna do an intro to coding very quickly. How comfortable with C# coding are we all?
Intermediate.
Intermediate? Jackson and Noah?
Fairly beginner, but I'm not scared.
Okay.
I'm pretty confident.
All right, so we're going to start with a hello world. We won't go too in depth. Nope, we won't go too in depth, but for those who know coding, you may have smiled when I said hello world. It is a beautiful little introduction to how coding works. Noah hasn't done C#, a couple of college Java classes. Okay, perfect. So into your project folder, I want you to click plus, create a new folder, and name this new folder scripts. That's where we're going to add our code from now on. In your scripts folder, I want you to click plus C# script. And you can see that by default, it's going to want you to rename this script. I want you to rename this script hello world with an uppercase H and an uppercase W. This is called camel case, or upper camel case, excuse me. It is called upper camel case. This means that the first letter of every word is uppercase, but you do not have spaces. Once you create a new script, you can double click on it, and your default script editor is going to open. This is where we may need to do some bug fixing with people. or some setup more accurately. So for me, I have Visual Studio installed on my machine. It is in fact the code editor that comes with Unity, and it's still to this day the one that I recommend. It just does a great job of being integrated with Unity that other code editors don't really do. But you can actually use any code editor here. You're just opening up a text file, essentially, is what script is. So you could use Sublime Text. That's another one I like. You could use literally TextEdit. That would be fine, although kind of terrible. So just let me know, anybody here, when you double click on your script, it should open up this script in your default script editor. If it did not do so, please let me know and we will try to figure that out with you. If I don't hear any complaints, we will press forward. All right. So this is a C# script. This is more explicitly, this is a Unity C# script, slightly different, still C#, but it just has some Unity stuff poured on top. I'm going to run down this file and we're going to talk about kind of the basics of this thing. And then we're going to get Hello World actually functioning before we write a script for Mario to make him jump. So this is your intro to C#. So first of all, on the top of our file here are our using statements. You won't really need to you won't really need to care about these for at least a little while as you learn C#. These are kind of like imports. This is us importing a library or something for us to use. These are the three that are by default imported into this script. If you're ever looking at someone else's code and it looks like, so for instance, text objects are not included by default. So text object equals new text object. If I wrote that line of code and I just like copied this from some tutorial online and I was like, why the heck? Like it doesn't know what a text is, but this guy is using text. If you're looking at some other example and it's not working, go check the using statements, because oftentimes you'll be following a tutorial and you'll realize that they actually have something that they're importing that you didn't import. So you can see here that this fixed the problem. Although I guess I'm not creating a new text correctly. Who cares? That's not part of today. All right. So that's the using statements. The next statement is the declaration of the class. Whenever we make a new object in Unity or in C# more accurately, we generally have three terms that we use, three words. The first word is our accessibility. This is who is allowed to see this script. So a public accessibility means that anybody is allowed to see it. The world is allowed to see it. When you are just getting started, pretty much everything you're going to write will be public. There are other use cases out there other than public, but we won't talk about them today for the sake of time. The next one here is the type of object. In this case, it is a class, which is for the most part, basically just a script. So when someone says, we're going to write 3 classes today, that means you're going to write 3 scripts today, 3 separate files. The third word is the actual name of the object. In this case, we named our script here, our class, we named it Hello World. This could be anything. You know, that would work just fine, although I encourage you to keep it human readable. And the fourth word, this is special for the declaration of the class. This is inheritance. So this is basically like the script that Hello World is learning from, is a child of, but that's a fairly advanced programming and you probably won't mess around with that for your first couple of months. So for today, definitely we won't worry about it anymore. All right, next most important thing are our brackets. Brackets are kind of like the punctuation of the coding world, the periods, exclamation points, etc. They designate bodies. They tell us what is contained, what is the contents of a thing. So first of all, brackets always have partners. So we can see here we have an opening bracket facing to the right, and then we have a closing bracket facing to the left. And in most script editors, and definitely Visual Studio, if I select one, it'll highlight the other one. So here's its partner. You can also see that if you keep your code clean, you can also see that they stay on the same indented line. So here is another pair of brackets and it's indented in. So we know that these are connected and that these two are not connected, these two. Now, whenever we use brackets, we're using it to designate the contents of something. So generally, in today's class and in these very intro classes, sometimes I'll generalize what we're talking about to keep it simple to understand for now. So generally, brackets always indicate the contents of the line that are above it. So here we can see opening and closing bracket. Everything inside of these brackets is a part of Hello World, is a part of the Hello World script. And here, everything that's inside of these brackets is a part of the start function. So let's do a little example. Is do stuff a part of start? Yes. Is do stuff a part of update?
No.
No. Is do stuff a part of hello world?
Yes.
Yes, that was maybe the one that might have tricked you. Yeah, it is still inside of the brackets that are connected to hello world. Okay, so those are our brackets. That's sort of the basic building blocks of coding. Now, we are now going to talk about functions, and then we're going to get our hello world script actually working. So a function is a single dedicated chunk of code that does something. So actually, sometimes I'll have us write a script, but that kind of takes too long. Why don't you, I'll just open this for now. I will have us, I'll have us install these scripts a little bit later. If you want, you can grab the entire scripts folder and drop it into your project. We will do that soon. I will actually need to do that, but I'll just show you the jumper script as an example of this. So the jumper script, by the way, all of my scripts, all the scripts that you guys have access to are well commented with all kinds of information in here. So one of the things that I recommend you do after this class is just kind of get curious, start playing with the scripts that I have available to you, start playing with their values, maybe mess around, delete a line or two, see what happens. You can always, go back and use the old versions of the code again. So jump is a function. It is a discrete piece of logic that does one thing. It's kind of like a component. It does one discrete thing. What do you think the jump function does? Good job, makes you jump. Jackson, hopefully that's what you're about to say.
Yeah.
So the jump function is exactly that. When you call the jump function, when you activate it, the jump function makes Mario jump. In Hello World, we started with these two functions. We have the start function and we have the update function. Now, these are two built-in functions that any new C# script in Unity is going to start with. The start function happens one time at the beginning of the game, and the update function happens one time every frame, which we're all gamers. We know that we have frames per second, and generally those frames per second are between 30 and 120 frames per second. So on average, 60 times a second, whatever is inside of here is going to happen. In here, it's only going to happen one time at the beginning of the game. So here's what I want you to do. In your start function, I'm finally going to have you write a piece of code. In your start function, I want you to write debug.log hello world. And then at the end of that line, I want you to put a semicolon. Debug.log hello world. All right. Now, when we come back to Unity, it's going to complain. I'm just going to delete jumper for now. When we need it, I'll add it back in. All right. It's complaining because we have jumper, but we don't have a partner script that the jumper needs. All right. So when we hit play, this debug.log should be printing hello world to our console, which is a classic way for people to learn new programming languages. It's one of the first things that you usually do. You get your game to print hello world to the screen. Unfortunately, it didn't work. Anybody know why this isn't working? Why hello world didn't print to the screen? Because this is a little bit different for Unity. That's a fairly important distinction. Why isn't hello world being printed to the screen right now?
Possibly just because we made the script doesn't mean we're using it.
Exactly. Yes. Remember that in Unity, the vast majority of the scripts that you're going to write are going to be components. And a component doesn't do anything if it's not actually attached to a game object in the scene. So even though we wrote hello world, which does, when it first exists, write hello world, it doesn't actually exist yet. We didn't add it to anything that is in our scene. So what you can do just to make sure this works, and then we'll move on to Mario's movement script. On our main camera here, click add component and find that hello world script. And as long as you don't have any syntax errors, you'll be able to find it. And then when you click it, you'll see that it attaches it as a component. It doesn't have any preferences. We didn't add any preferences to it, but it does attach it. And then when we click play, hello world gets printed to our screen. So now that script is actually being run. That start function is actually being called. And we have written our first component in Unity. Congratulations. Amazing. All right. Good stopping point. Does everybody have hello world printing to the screen? Thumbs. Alexa, you got hello world? Noah, you got hello world? Kirk, you got hello world? Thumbs
Yep.
all around. Fantastic. All right. So let's do one more thing to our hello world script to show you what a variable is. So a function is one discrete function or method. That's a fairly interchangeable word. If somebody says a method, they're talking about a function. It does one thing. In this case, this does everything that our game wants to have happen when hello world first exists, right? We could also write a function that adds two numbers together, and we would call that function sum. And it's a sum function, and we call it whenever we add two numbers together. We'll have some other examples of functions in a little bit. But the other sort of core component of programming is a variable. So after line 6, I want you to make a new line, and I want you to write public string text to print. And then I want you to hit equals, quotation marks, whatever I want, and then put a semicolon at the end of the line. Now you'll notice that I always have a semicolon or an opening bracket. This is another one that's a little bit of a generalization, but for the most part, I will always end my lines in Unity C# with either a semicolon or with an opening bracket. So even though this is on a new line, this still sort of counts as ending the line. That's like the period in a sentence. That's how the code knows that we can move on to the next thing. Okay, so in order to use this, this is a, I guess let's cover this first. This is a variable. Variable also has the accessibility, who's allowed to see it. Public means everybody can see it. It has the type. In this case, it's a string, which is just some text. And then a name. In this case, we called it text to print. This is its default value. So I'm going to take this variable and use it now. And I'm going to use it by deleting this hello world text here. So it's just the parentheses and then pasting text to print inside of the debug.log. All right. And then when I come back to Unity, when I click play, we'll see that instead of hello world, Unity prints whatever I want. And even more interestingly, now that this is a public variable, if I look at the hello world component that is attached to my camera, I have now added, because of that public variable, basically a setting. And this setting currently says whatever I want, text to print, whatever I want, but I can make it say, anything, whatever I want. And now when I hit play, that's going to be the text that actually appears on the screen. All right. So that is our hello world script. Let's move on and get our player actually doing something. Superior method of bracket spacing, says Noah. Oh, bye, Alexi. Thank you for being here. We'll email you the recording later. Oh, he's already gone. I missed the chat for a little bit. All right. So I agree, by the way. Some people will put brackets like this, and that's fine, but wrong. This will not break anything. And really, I can't be upset with you for your preferences, but I personally prefer brackets to be on their own line. It just feels way neater to me. And there's nothing wrong with extra spaces. Yeah, I don't understand it. Well, whatever. All right. So let's, we don't need our hello world script anymore. Let's go back to our scripts folder. We're going to click plus C# script. And I want you to write player controller. We're going to write our first actual sort of functioning piece of code, the thing that we're going to actually use in the game. Player controller with an uppercase P and an uppercase C, also called upper camel case, and then open that up when you're ready. Now I got to call this out because it happens so often. If you ever write the name of your code incorrectly, so let's say I did a lowercase p here, and I'm like, dang, I got to uppercase that P. Very important note, and I'll say it twice again. Whenever you rename a script, you have to rename it in 2 locations. You have to rename it here, the file itself. So there we go. I can uppercase this now. There we go, uppercase P. And double click on it to open it and rename it inside of the file itself. If this is lowercase, and then I come back here and I open this up, we'll see that this is still lowercase. These 2 things are not linked. I actually have to change the name in both of those locations. So just to call that out, I'll say it again. If you ever need to rename a script in Unity, you have to rename it both in the project tab, the name of the file itself, and inside of the script, the name of the class. All right, we got a player controller. The player controller is going to do a couple of things. First of all, we're going to need two reference variables. We're going to need a public mover, which I'm just going to call mover. And we're going to need a public jumper, which I'm just going to call jumper. And we'll notice that we have things underlined in red. The reason that these are underlined in red is because these are scripts. This is code or classes that I wrote for you that we have not yet imported. So we can fix these problems by simply importing the scripts folder that I have included for you. So you can download this entire scripts folder and drop it. Actually, I will exit out of that. I can't. Great. There we go. Since I already have a scripts folder, I'll just select all of the scripts individually and drag and drop them here. And there we go. We have all of the scripts. Now, by the way, you'll also notice that we have a completed player controller, a completed flag, and a completed coin. These are the completed versions, the finished versions of the scripts that we'll write today. Probably, given that it's 7:15 already, we'll probably only write the player controller today. And we'll just use the coin and flag by itself. But if you want to look at the full version of the player controller, you can open this up. Or if you're having some kind of issue, you can just use my version instead of the one that we're going to write. But let's go back to our player controller. And we should see now that mover and jumper are no longer underlined in red because it knows about the mover and jumper. It knows what a mover is. It knows what a jumper is. Now, this is what we call a reference variable. A reference variable doesn't create a piece of data. It points to a piece of data. So in our hello world, this text to print is an actual new piece of data. It's a piece of text that we're saving. In our player controller, we're going to have a separate component of the type mover and a separate component of the type jumper that are both attached to Mario. And then the player controller simply tells those components when to move or when to jump. This is a pretty common architecture. We'll have the thing that knows how to do the thing and the thing that tells that thing when to do it. The reason that this is nice is I can use these exact same scripts, the mover and the jumper, on an enemy or on another player. And we just change who actually tells that thing when to activate. So the Goomba has a Goomba script that tells it to move left and right versus Mario, who has the player controller that listens for arrow keys. Okay, so the first thing for us to do here is probably the easiest thing will just be to get this thing jumping. So let's go down to the update function and let's talk about conditionals. So I'm going to type a thing out and then we'll talk about it. So just copy this for now. So I'm going to say if input dot get key down parentheses key code dot up arrow. And then under that, I'm going to make some brackets. So copy that down. I'm going to talk about it in just a second. If input dot get key down key code dot up arrow. All right. So a conditional, who can tell me what a conditional is? I think the three of you probably know this just fine, so we probably don't need to cover it. But let's see, what is a conditional?
It's a type of function that evaluates a value or
Yes,
a sequence of values in a formula.
I don't think it would be considered a function, but somebody can correct me if I'm wrong about that. Regardless, yeah, it's a piece of code that basically just says if this thing equals true, then we're going to do stuff. So it's simply a way for us to check a statement and only do the action if this is true. So quick example. How about this? Is greater than 3. Are we going to do some stuff? Anybody? If example int is greater than 3, we're going to do stuff.
Yes, we're going to do stuff.
Indeed, because 5 is greater than 3. And then in this case, we would not do stuff because 5 is not less than 3. 5 is greater than 3, right? So that's all a conditional is. So what we're doing here is we're saying, hey, if input.getKeyDown, input is a static function, a static class that knows a bunch of stuff about input. It has a function called getKeyDown, which just asks the keyboard if a particular key has gotten pressed. And then we can tell it which key to listen for. So all this is saying is, hey, if we click the up arrow, then we're going to do some stuff. In this case, the stuff that we're going to do is just jumper.jump. We looked at the jumper script a little bit earlier, which we can open back up now that we have it back in our file, back in our project. And we can see that the jumper has this jump function, which doesn't take in any parameters. It just does. So that's all we have to do to get jump working. So let's come back to Unity now. And let me know if I'm popping back and forth too fast or if people need the script or whatever. If I click on Mario and I come down to add component, we're going to have to actually attach the player controller, right? I'm going to click add component, player controller. The player controller has a mover and a jumper box that are currently empty. If I click add component mover, I can add a mover to Mario. And if I click add component jumper, I can add a jumper component to Mario. Now, you might think that you are now able to click play and make Mario jump. But unfortunately, that creates a crash, a null reference exception. Can anybody tell me why this is not working? What is a null reference exception? What's wrong? The answer is right here in the inspector. What's wrong?
There's no reference to the objects inside the player controller.
Yeah, remember that I called these things reference variables. These are not tracking data. This is not a mover. This is a reference to a mover that already exists right here, but we haven't actually made that connection yet. So this is another very, very common architecture in Unity where you have these empty boxes, these public variables that you then drag and drop information into, like we did with a sprite, for instance. So if I drag and drop, I can actually click this gray box and drag and drop the mover into this empty box here. And now the player controller on Mario knows about the appropriate mover that it should be editing. And you can do the same thing with jumper. The reason that this is important is because I could have dropped like the Goomba's jumper in there and made it so that whenever I hit up, the Goomba is jumping, right? So the player controller just needs to know about which jumper, which mover it's actually talking to, it's actually editing. Now, whenever you see a null reference exception, that's actually one of the best errors you can run into because 99% of the time it means exactly the same thing. It just means you forgot to hook something up in the inspector. So now that I've done that, if I hit play, we should have a living, breathing Mario. Wow. He can't move left or right, but he can jump. Gosh darn it. All right, this is another great check-in moment. Let's make sure everybody has jumping working. Kirk.
Okay, can you go over that last portion again?
Yes.
Because I currently still have none mover and none jumper.
Null reference exception? Yeah, totally.
Yeah.
So very, very common architecture. Basically just dragging and dropping is the actual architecture,
Okay.
right? So the player controller has two reference variables, the mover and the jumper, which you currently see as none, because right now it's referencing nothing, which is why when it tries to jump, it goes, I don't know what you're talking about. So in order to actually hook them up, all you have to do is click and drag the component itself. So like this gray bar, right where its name is, right into that empty slot. And it will accept that as an input. That work for you?
Okay, yeah. I see what you're saying now.
Yeah, so this is, we have surpassed Cyberpunk 2077. True. No, I like you. You're funny. So yes, this is, there's a couple things that go wrong here pretty frequently. One thing that people try to do sometimes when they're fresh to this is they'll try to drop the actual scripts from their project into those empty slots. And we'll see that it actually doesn't even let you. It needs an existing jumper and mover that is in the scene. That's why this is a reference variable. Now, something else, this is kind of funny. So if I clear these out, if I set these to be none again, the ability for me to drag and drop the component, click on the mover, drag and drop the component, is actually also relatively recent. That's maybe about a year old. What you used to have to do is drag and drop it from the hierarchy. I would have had to actually grab Mario itself and drop this into this jumper slot, and it would search Mario and find the jumper component. So you can actually do both, but it's a little bit easier to just drag and drop the component. So there you go. Now that you have it hooked up, you should have jumping stuff. So Noah and Kirk, do you have jumping? And Jackson, did you fix it?
Yes, I figured
Yep.
it out. Thank you.
Are we
Jumping
Gucci?
seems to work.
Fantastic. Ah, yeah, baby. All right, great. So let's get moving to work then. The mover is going to be slightly more complicated, but still basically the same stuff. If we open up the mover script, we'll see that instead of a jump function, mover has accelerate in direction, which takes in a vector2 direction. So once again, I'm going to just type this out and I'm going to ask you to write it down and then I will go over it. So here we go. I'm going to say if input dot get key, and you'll see that I did get key and not get key down. I'll talk about that too. Left arrow, mover dot accelerate in direction, parentheses, new vector, new vector2, -1, 0, semicolon. And then I can copy that whole line, that whole if statement block, and I can replace left arrow with right arrow, and I can replace -1 with +1. And that's it. That is the code to make us move left and right. I'll leave that up for a second. I'll talk about it. Okay, so the if statement, we already know what conditionals are. No problem there. Get key versus get key down is a very important distinction. And actually, the last time I taught this class, I messed it up and I left get key down there. Does anybody know the difference, or can you guess the difference between get key and get key down? There's also a third option called get key up.
The difference between get key down and get key is that the down version only tracks the frame which the button was pressed. Get key is persistent, so it tracks as long as it's pressed.
Yes, it's a Magnum pistol versus an assault rifle. Instead of a get key down, it means the very first moment that the key first gets pressed down, we will register that input. Get key checks every frame if that key is currently pressed. So essentially the difference is a jump where we click it and it happens one time, or a move where we click it and hold it and Mario actually slides. So this is actually very important that we get right here. The third option is get key up, which is a bit weird, but is sometimes useful. That's the opposite of get key down. It happens only once, but it happens that first moment we let go of the key. So sometimes we might want that in very specific situations. But that should be all we have to do. The next thing is just the arrow that we're using, left arrow and right arrow. This could be whatever you want, by the way. I could put just an A in there if I wanted WASD controls, or I could use the space bar or something like that. You can look up the different key codes. And then we have this accelerate in direction, which just moves us in a particular direction, but it takes in a vector2. What is a vector, anybody? Somebody tell me what a vector is.
It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
Indeed, sir. Yes, basically, a vector is an arrow in space. So if I've got a classic grid here with an X axis and a Y axis, a vector is an arrow starting at 0, 0 with one end of the arrow pointing in some direction. So if I make a new vector2 and I pass in a 1, 1, like that, that's going to wind up with a position at an X coordinate of 1 and a Y coordinate of 1 right there, giving me a perfect 45-degree angle. By passing in -1, 0, X of -1, which is actually over here, and a Y of 0, that winds up giving us a perfect left-facing arrow. And then by passing in a X coordinate of 1 and a Y coordinate of 0, that winds up giving us a perfect right-facing arrow. So our mover can actually move us in any direction that we give it, but we want it to move it in exactly left and right directions. So if we come back to Unity now, once again, and give it a second to compile that script, make sure it all looks good. When I hit play now, Mario should be able to drag himself around the world and do a little roly-poly dance. Amazing. Forgot about that one. All right. So you should, that is correct, given our code so far. Mario currently does a little break dance or something. I don't know what that is. That is actually simply because we are using a capsule collider on Mario. So he actually has a round bottom. So when we drag him left, he winds up rolling onto his side. The reason that we use a capsule collider capsule colliders are very common for human-shaped entities that don't need to be too picture perfect. So not a fighting game or not a shooting game, something where the collision is not terribly important. The reason that a lot of people use them is because the rounded bottom is actually a big asset. If Mario was a square collider, if he was perfectly square and this thing was just a little bit too high, he would get stuck on that edge. Versus the capsule collider having a rounded bottom allows him to ride that edge a little bit and not get so easily stuck on things. It doesn't have to be as perfect. However, the negative is that he can roll, but we can fix that very easily by clicking on Mario, coming down to our rigid body 2D, and then we can see this constraints drop down right here has a little tiny gray arrow. If you click this little tiny gray arrow, anytime you see that, that's a drop down indicator. So I can actually compress the whole rigid body, for instance. If I click that down to see inside of the constraints, there's a freeze rotation Z. And if I click that, Mario will now not be allowed to rotate. And so therefore he will slide instead of spin. So now we got a Mario who can move left and right. All right, another great check-in moment. Does everybody have a slippity slidey Mario? Ah. Right.
Just finding the rotation properties again.
Yep.
Oh, rigid body.
Yep. Yeah, rigid body 2D. Under constraints, we'll drop down. Click freeze rotation Z. All right. Only remember the definition of vector from Despicable Me.
Yeah, no,
He's
I'm glad
playing
you
Dark
picked that one up.
That's great. Yeah, we should now have a Mario who can slide around, which is fantastic. So we notice though that even though Mario can move around, he now gets lost off the side of the screen. Now that we're at the half-hour mark before class ends, this is where we'll generally just start using the scripts that I have already written for you. I'm hoping that I've given you just enough code that you can kind of go from here. I recommend that you take another tutorial or two, that you look at more sections of code that I've already written for you. Also that you take a look at the handout. The handout has some like a coverage of what we actually talked about today, as well as some extra challenges for you. So this is a great place for you to start to continue to grow your C# and Unity acumen. But for the rest of class, we're just going to use those built-in scripts so that you can get a functional version of Mario and get more practice with the Unity engine and not spend all your time trying to code. So the first thing that we'll notice that we want to fix is the fact that the camera doesn't follow Mario. So Mario can just walk off the side of the screen and we can't really build a very big level given that this one screen space is all that we're allowed to see. The way to fix this, very, very common way to fix this in the gaming industry, is to simply make it so that the camera actually follows Mario around. So instead of it just sitting here statically, it will actually follow him. A more advanced version of this might give you some, what's the word I'm looking for? Some sort of acceleration and deceleration. So it might kind of like speed up and slow down as Mario moves. In this case, though, we're just going to make it perfectly one-to-one follow him for the sake of just having an easier script that you can hopefully understand it. But we'll attach that script that we call a follower that we wrote for you by clicking on our main camera, going to our inspector, coming down to add component, and adding a follower to the camera. Now the follower script does something very simple. It attaches to an object and then it has a followed transform. This followed transform is the thing that the camera will actually follow. So in this case, we want to drag and drop Mario into that empty slot. So we are clicking on the main camera, clicking on add component, adding a follower script, dragging and dropping Mario into that followed transform. Now, when I click play, the camera will snap to where Mario is and perpetually follow him. So now we can make a much bigger level. Now we'll see, by the way, that Mario is too impotent to get over this square right here. One feature / bug of the way that I've showed you how to build this game is that Mario is allowed to wall climb. And in fact, actually, this is a good moment to bring this up. Mario is actually allowed to fly. I don't know if anyone noticed that. If I hammer up, Mario can keep flying upwards. I actually have another component for that we can attach really quickly. The jumper is fairly robust. And if we look at the jumper, we'll see that it says if ground detector is null. So if it does not have a ground detector, or if the ground detector detects that we're on the ground, we are allowed to jump. So the jumper can work with or without a ground detector. But if we want to make Mario only allowed to jump when he's touching the ground, we can add a ground detector to Mario, which is another component that we wrote for you. So if we click on Mario, go to add component, search for ground detector. And now this thing its only function is to detect whether or not we're currently touching something. So if we drop Mario into this world now, he can only jump when he's touching the ground. However, this is still not a perfect solution. He's actually allowed to still wall jump. However, I didn't want us to write too complicated of a solution for you guys. So that's just a thing. In your version of Mario, Mario can wall jump. It's a feature, not a bug. All right. We're building the groundwork bit by bit. Is everybody good so far? Anybody need me to slow down or cover something? Please let me know if so. It just works. It's amazing. All right, Jackson looks good. All right, so let's add some interactable stuff in our world. We have, I think we should probably get to all of them since we're not actually coding it. We have a coin, as well as the flagpole that we can touch to win the game, and we have a piranha plant that can actually destroy Mario. So let's start with the coin. I showed you that you can drag and drop sprites into your sprite renderer, or that you can click this little circle and pick the sprite. But there's actually a third way that's even faster. If I click and drag one of my images from my project folder straight into the scene, it'll do kind of janky shit, which is new since the most recent version of Unity. So I don't know, that's a bug they have to fix. But it will also still correctly create a new game object with a sprite renderer with the coin defaulted into that sprite renderer. So while the coin is massive, we can fix that. This gives us a really quick way of just adding new sprites to our world. Yeah, very handy. So I'm gonna make that smaller though. It is a super massive coin. What does 0.2 look like? Yeah, it looks great. All right, got a coin in our world. Now the coin currently doesn't do anything. If we had more time, we might write the coin script, but we only have 20-ish minutes. So we'll just use the scripts that are here already. And then you are more than welcome after class to check out the scripts and try to figure out how they work. I'm still going to show this one because there's one important point to make with it. So I want you to add component, completed coin. And then I want you to add component collider, whichever collider seems to fit best. In this case, it seems like a capsule collider is the right choice again, because the coin is kind of capsule shaped. It looks like it didn't get the shape quite right, so we can manually edit the size a little bit until it more closely fits the coin. That's good. And now when we hit play, when Mario runs into the coin, unfortunately, nothing happens. So this is the important point that I was talking about. The coin is currently a standard collider. If you open up the completed coin script, we'll see there's this function here called onTriggerEnter2D. Now, something to call out when you're watching this recording or when you're trying this on your own and understanding how Unity works. The other sort of version of this is what's called onCollisionEnter2D. OnCollisionEnter2D is a special function like start or update that gets called when something runs into this game object, when something runs into this collider. OnTriggerEnter2D is a special function that gets called when something runs into this trigger. However, this coin is currently a collider and not a trigger. This is a bit of a confusing distinction. If I click on my coin and I come over to my capsule collider 2D, we'll see that the very top option there is trigger. And if I click that, this collider is now considered a trigger. And then if Mario walks over and touches this coin, he will indeed pick it up. The coin will delete itself and coin collected will get printed down here in the console. Does anybody know the difference between a trigger and a collider? Or can you guess?
The difference between a collider and a trigger is a collider typically acts as an object to collide with, and a trigger does something in response to a collision state.
Mm-hmm. Yeah, the core difference is that a collision actually impacts, collisions. It actually has a collision. So a door is a collider. A trigger is something that still wants to register when it gets collided with, when it gets touched, but it doesn't want to have a physical body. It doesn't want to actually stop that movement. So the way that we often use a trigger in the game industry is if, let's say we're playing Ocarina of Time, and we're walking into the very first boss fight with Goma in the Deku tree. And we walk through this open doorway, and then a cutscene starts. The way that the game probably detects that Link walked through that doorway is that there's a big trigger in that doorway. There's a big box, a collider, but that is set to be a trigger. Now, Ocarina of Time is not made in Unity, so this is not quite one-to-one, but that's how you can think about it. Something that detects a collision, it knows that Link walked through, but it doesn't actually impact Link. It doesn't stop Link from walking through it. That's how a trigger works. That's what a trigger is. Now, I only chose that for the coin in order to have an example of a trigger in our game, just so that you guys can get a sense of why and how we might use triggers. All right. Now let's add a piranha plant to our game. So we're going to, we can do that quick trick again. I'm going to click and drag my piranha plant from the project into my world, and it's being crazy again. That's this is the first time I'm using this version of Unity, so that must be a bug that they are going to have to fix sometime soon. This is great. I'm going to shrink the piranha plant down so it's not quite so massive. That looks a little bit small. Yeah, that looks like a piranha plant, right? We'll put that somewhere. Maybe let's make another platform. So you got to get by this plant or something. Maybe like there, so it's not impossible. There we go. You guys can always play around with this level later. It's one of the best parts. All right. Now, the piranha plant, as it stands right now, is not going to pose any problem to Mario, but we have another pair of scripts that I will show you how they work in order to actually destroy Mario if you touch this plant. So first things first, the plant needs to touch Mario. It needs to have a collider. So let's add a component to the piranha plant. And we'll have to decide which of these colliders is best for the piranha plant. I feel like you could actually argue that this should be a box collider because it's kind of box shaped up here at the top. But I also kind of think it should still be rounded. This is a sort of game design trick. You want to give the players the benefit of the doubt. If the player gets killed by this, if it touches this and dies, they're going to feel cheated. Like, oh man, I didn't even touch the plant. But if they, let's see, if they go right here by this little white lip and they don't die, depending on the type of player and the type of game, they might actually feel good. Yeah, it'll feel a little forgiving because they'll be like, ooh, oh my God, I think I should have died, but I didn't. That's actually a really exciting moment for your player. So for the most part, you want to give your players the benefit of the doubt. You actually want to give them a little bit of breathing room and only really kill them or hurt them if they really touch this thing. All right, so we have a capsule collider on the piranha plant. The piranha plant can now use two scripts. We're going to use one script on Mario and one script on the piranha plant. It's a pair of scripts that I have written for you. And that is the destructible and the destructor. So those are a pair of scripts that work together, and that's exactly why we have them here as an example for you. Some scripts can communicate to other scripts depending on their type. So the destructible is a thing that knows how to be destroyed. It has a maximum number of hit points. The default is 3, but because it's public, we can always set it in the inspector. So we can make it 1, which is like classically how Mario works, right? And then when something touches it, it's allowed to take damage and also heal damage if we wanted to heal up Mario. This will then kill Mario when he runs out of health. It will actually like delete Mario out of the scene, basically. The destructor is pretty simple. It's actually very simple to our coin, except this one is your example of on collision enter 2D, on collision enter instead of on trigger. So it says, hey, if a collider runs into me, I'm going to check if it's a destructible, if it has a destructible on it, using this function called getComponentDestructible. So it's actually going to search Mario for a destructible, and if he has one, then it's going to deal damage to that destructible. So don't worry if that didn't make too much sense. That was meant to be just a super quick intro. That's sort of, especially this last half hour of the class, just trying to get you once again over that hump, hopefully just enough understanding for you to start to experiment and work on your own games. So let's make it actually work. On my piranha plant, I'm going to click Add Component. I'm going to find Destructor and add a Destructor to Mario. Excuse me, a Destructor to the piranha plant. And then I'm going to make it so Mario can actually be destroyed. I'm going to click Add Component, and I'm going to add a Destructible to Mario. I'm going to make it so that Mario can actually take damage. And I'm going to give Mario just 1 hit point, since that's usually how Mario games work. Now, if I walk over If I pick up the coin, if I walk up here, wall jump a little bit, and run into the piranha plant, Mario will actually get deleted out of the scene. He will get destroyed. If I click play, Mario is back. Don't worry. But now we have an enemy plant in our game. All right, one more check-in moment. Is everybody good? Do we have a deadly piranha plant in our world?
Yeah.
Awesome.
One question. I
Yeah.
probably ended up missing it. It has to do with the coin. So we talked about triggers and collision.
Yeah.
I still have a hard collision coin.
Yeah.
I probably didn't change something. What do I need to do for that?
So typical. Don't worry about it, man. This is, I still don't know why there isn't just a collider and a trigger. It's just a checkbox. So if you click on the coin,
okay.
yeah, there's a capsule collider, and then one of the top options there is just trigger. So you're dramatically changing its behavior with this one checkbox, but oh well.
Okay, awesome. Thank you.
Yeah, that's all you got to do. Yep. So the last thing we'll add is the flagpole, which we don't really have enough time to talk about UI, but that's another thing for you to experiment with on your own time. I'm gonna first of all make Mario jump a little higher because he can't even make it over that piranha plant. So I'm gonna go over to this jumper down here. It's the kind of stuff you can play test for. Maybe make his jump force 10 or so. And I'll lower this piranha plant down a little bit as well. So that's like a little bit more interesting by itself. And then also that'll make it so I can actually jump over it. And then I'm going to add my flagpole to the world. Here's my flag. It's a bit humongous, but as usual, I can make that smaller. How about a 0.5? Maybe? Yeah, that looks right. And then I can add component, a collider. In this case, I feel like a box collider is probably right, but then I'm going to make it much more narrow, like a 2 even. Yeah, that looks good. And then I'll stick that in my world. And then on my flag, I will add component, completed flag. This is once again a script that is meant to allow you to write it yourself. But for now, we're just going to use this one since we're coming to the end of our time. Now, if I click play, Mario can pick up the coin. He can jump a little bit higher now. Ooh, a lot higher. That might be too high. And he can jump over that piranha plant with no problem. And when he touches the flagpole, oh, dang. The flagpole is also a trigger. My B. So click on the flag, go to the box collider 2D on the flag, click is trigger. And then click play. And now if we go and touch the flagpole, we will actually win the game. And we'll see, so it's a little bit unsatisfying of an ending. If we look at the console, we can see that it does print out game 1, but it doesn't do anything else. The other thing that it will do, if you look at your flag, we'll see that it has a win screen that currently says none game object. This is actually a way for you to hook up a UI element. Any game object that you drop into this box will get turned on. It will activate itself when you drop it into this box. So I'm gonna, for the sake of time, we're not gonna do that right this second, but that's something for you to experiment with in the future. I will also send around a video of a different walkthrough of this class where we went for like 2.5 hours instead of 2 hours, where we covered some of the stuff that we aren't covering today. So you can always take a look at that if you're curious. But this is just a place for you to drop something in that gets turned on. Here's sort of the quick version. If I click on any object in my scene, including some UI, if I add UI elements, at the very top in the inspector, there's this tiny little checkbox next to the name. When I click that, the object actually gets turned off. So you can see the coin is currently turned off. This will mean that the coin still exists, still has a place in space, and we can still see it in the hierarchy, but the player can't see it in the game and can't interact with it. So all this flagpole does is when something touches it, it turns it from off to on. So actually, to see this as an example, I could always drop the coin in there. And now when I run my game, the coin starts as off, nobody can see it or touch it. But then when I touch that flagpole, the coin will actually appear. So what we did in other versions of this game and what you can do is created a UI that pops up above the player that says like you won the game, and that'll pop up when you actually touch the flag. All right. So that's where I think we're going to stop for the most part for today. I'm going to make sure we have a chance to ask questions. Does anybody have questions or comments or anything like that for the Mario in 2 hours class?
No, I appreciate it. I think the only thing to note is something that I'm still trying to get used to is that if you are currently in the play state of the game and you start messing with stuff and you stop playing, everything gets reset, which is a bit frustrating. But
That's funny. I often actually bring that up in class, and I didn't mention it today. So that's a great point. For either Noah or Kirk, if you aren't aware of this, when you are running the game, when you are actually playing the game, if you do any edits in the inspector or in the scene, so for instance, if I moved this piranha plant up, if I'm like, yeah, that plant is way too low, and then I stop playing my game, Unity will actually not save those changes. It moves the piranha plant back. And that is on purpose. It does that on purpose so that you can play around with your game and just like experiment without worrying about like breaking everything or undoing everything. A quick fix for you, or not really fix, just like a way to make it more obvious for you, Jackson. If you come up to the Unity, like very top of your window, the Unity Preferences tab here. And is it not under Preferences? What is it under? I thought it was under Preferences. Am I crazy? Oh yeah, it is. So if I come up to the Unity Preferences menu item, and then I go to Colors, right here, kind of sitting by itself, is the Play Mode Tint. Change that to just like a really obvious color. You can see that mine is red. So that way, at the very least, when you hit play, it's going to be super obvious that you're actually running your game. So you'll be less likely to make changes that you don't wind up saving.
okay, awesome. Thank you.
Yeah, for sure. Any other questions or anything like that? All right. So this is, if you make changes while playing, are they actually made live while the game is running? Yes, that's another great question. So that's part of the reason that it doesn't save stuff. It is actually made live. Now, there are restrictions to what works for this. If I change my code while the game is running, the game will crash. But there are stuff that you can change. Anything that you can change in the inspector will work just fine. So right now, Mario is jumping, let's see, about 3 blocks into the air. I can change his jump impulse even while the game is running, the jump force, to like 20. And now Mario will be Super Mario and jump way the heck into the air. And I can change that back to like 3. And now Mario will jump like crap. And I can do anything in the inspector, for the most part anyway, while the game is running live. I can even move stuff. I could like rotate Mario and make a really weird version of the game, or rotate the camera. That's kind of fun. That's still the camera. Rotate the piranha plant. I don't know. All this stuff is allowed to be changed. Oh, I think Mario, will it let me rotate Mario? It does. Okay. So even though the rigid body tries to resist rotation, it still lets the actual user rotate Mario. Yeah, so that's exactly the point. The whole idea is that you can fine tune stuff without worrying about breaking the game too much. All right, so I hope you guys enjoyed. This was put on by the Indie Game Academy. I am Willem Delventhal, the headmaster of the Indie Game Academy. Kirk here is a graduate of our level 3 program. What you just experienced is IGA level 0, which is just sort of our like taster class meant to get people up and running and building games. Now, because I know that you guys are cool and not trolls or anything, I can invite you to the community should you want to be a part of it. We love having cool people inside. Our sort of whole goal is to support game creatives in paving their own path. We love people starting their own studios. We have helped students start multiple studios, and we love getting people into game careers, which is what Kirk is working on right now. Although, Kirk, you're working on both right now. You're a busy man. We have 3 programs that we run, levels 1, 2, and 3, as well as, I guess, level 0, to sort of our taster to get you up to speed in Unity. And then level 3, which is our big head honcho, is our indie game accelerator, where you actually get sorted into a wizarding house. It's like Harry Potter or something. And then you work with that wizarding house over the span of 3 months under the tutelage of myself and 6 other industry professionals that we bring in. It's like a mini GDC or something, to learn how to make games, to learn the holistic game development process. So you actually work with a team to publish an original monetized game in 3 months. So if that sounds interesting, feel free to reach out. Actually, I'll give you this if you want to schedule a chat with me about that, or just about life. Click on that and schedule a call and we can talk sometime. Otherwise, thanks for coming, y'all.
Awesome. Thank you very much, man.
Heck yeah. Thank you, Jackson. Have a great day. And thank you,
This
Noah.
was great.
Of course. Have you done one of these with me before, Kirk?
This is actually the first time that I've done this little level 0 class. I have the one for the Flappy Bird saved in my email, and it's on
Okay.
my list to get done.
Yeah.
I'm just having to shift priorities around again.
Yeah.
So just trying to
finding
make sure.
time for stuff is a real problem.
Yeah, but thankfully my next week is clear, so it'll definitely
Nice.
be on the top of the list coming next
Check it out.
week.
Yeah, Kirk
Yeah.
just finished the 3-month program with us. So Kirk is on a cooldown phase. He just published an original game called Row Station, which is a pretty sweet little mobile experience.
Yeah, for sure.
Awesome.
IGA is a great place to learn game development, and you'll get a lot of insightful knowledge and practical experience, if you come aboard. I actually learned a lot about like ECS mindset design from this little level 0 course alone. Like from what I know and seeing it like spaced out and separated the way it is, I'm starting to get it. I still need a little more, but this is awesome.
Yes. Well, Kirk, we sent out the level 1 program to all the graduates, so maybe check that out instead. It definitely goes a little bit more in depth.
Oh, perfect.
But anyway, thanks, guys. I'm gonna take off because I'm tired and I'm ready to just play some VR games and go to sleep. But thank you for being here. Cheers to everybody. Hope you come join and hang out with us. Bye now.
Thanks, man.
Thank you.
Take care.
I'll be sending out the recording in the next couple of days. Adios.
Sounds good.